All right, this is the continuation of 1B1, which is the last section we had started in class. Remember, I said I was going to keep that on the original due date of Monday's homework next week. So the 1B2 and 1B3 and the quiz for 1A and 1B, that will be moved to the next due date, which is the Thursdays for our class. So just FYI, that's going to be changing in the calendar, but you can just look at that and see, in the calendar yourself when you're looking. Let's just a recap. We were talking at the very end of the last 10 minutes how if you're multiplying 2 powers of 10, we add the exponents. If we're dividing with 2 powers of 10, we subtract the exponents, and it has to be numerator minus denominator. So that was what we were talking about together. And then we looked at this problem. So we said if we want to multiply two scientific notation numbers together, you multiply the parts that are just regular numbers together, so like the 3 times the 2.1. Then we multiply the two base 10s together, which means we add their powers. So that's the 10 to the 5th. We said to be correct scientific notation, you can only have one digit, and it has to be a 1 to a 9, not a 0, in front of your decimal point. And then this guy right here has to be an integer. So as long as both of those things are true, we are in proper scientific notation. Okay, so we're going to try some together. So we have the 2.3 times 10 to the 6 times the 3.2 times 10 to the negative 3. So we're going to start off with multiplying the number parts together. So 2.3 times 3.2. That's going to give me 7.36. Then we'll have our time symbol. We got 10, and it's 10 to the 6th plus negative 3, because we're multiplying our bases together since this is times in between. So we're adding those powers. So if you use the calculator, you can see that 6 plus negative 3 is a positive 3. Now, is this correct scientific notation? Only one digit in front of the decimal, and it's a 1 to 9, so we're good there. And this is an integer, so this one is good. All right, let's do the next one. And we won't probably get any that are needing adjustments until we've practiced this for a bit. So we are going to get some that aren't proper scientific notation in a minute, and we'll talk about how to handle that. So we've got 4.3 times the 1.6, because again, we're multiplying between our two parentheses. That's going to be 6.88 times, and then we've got, I'm going to write this over here again. We've got a 10 to the negative 7 plus a negative 3. Now, these are both negative. So when you add same signs, you add and keep the sign. So that's going to be 10 to the negative 10. Okay, so these are also, this is fine for proper scientific notation. There's only one digit in front of the decimal, and it is a 1 to 9. That can't be 0, but it can be a 1 all the way up to a 9. And then this is an integer, because remember, integers can be positive or negative. Okay, when we're dividing, the steps are very similar, except we are doing the process for division. So when you see divide in between your two parentheses, you're doing top one, which is this first one, divided by the bottom one. So notice I wrote 8.8 divided by 2.2. That comes out to 4. And then remember, our rule is we subtract the exponents, but it has to be the top exponent, because if you think about this in fraction form, if this was a fraction bar, this 8.8 part is on top. And then we're subtracting the power on the bottom, which is a 3. So 8 minus 3 is 10 to the 5th. So this would be 4 times 10 to the 5th. And that is also proper because it's, even though we don't see the decimal, it's right behind that whole number. So there's only one digit between 1 and 9 in front of the decimal, and this is an integer. So we're good there. So we're going to try this one. So I'm going to write my work out to the side. So 8.12 divided by 2.32. So that's going to be our part for our number. So let's get our calculator out. 8.12 divided by 2.32. That's 3.5. I'm just going to write that out here. So that's going to go in front here times 10. And then I'm going to write my steps. So again, 10, it's the top one, which is the 5, because remember, it's whatever came before the division sign. That's your numerator, minus the exponent in the bottom, which is a 9. So sometimes you will get a negative when you do this subtraction step because you have a smaller power on top than you do on the bottom. So 5 minus 9 is a negative 4. And this is in proper scientific notation. It meets the conditions. Okay, so the next logical question would be then, what do you do if it doesn't meet the conditions? And we have a little saying to help us adjust so that our scientific notation is in proper form. Anytime you're asked to write your final answer in scientific notation, they always mean proper form, okay? So that's the one digit in front of the decimal point and then integer for your exponent. Okay, so this says, say I get something that's not in proper form, then I can use LARS, which if you think about it, there's actually kind of like a comma separating these two groups of letters. that tell us how to adjust it. So it says if it's left that we need to move our decimal, we're going to add to the exponent. If we need to move our decimal to the right to fix the front number, we're going to subtract from our exponent. And it's actually specifically, if you need to move the original decimal left to reach the target location, you're going to add that number of places it moved to the power. Okay. If you need to move the original decimal right to reach your target location, you will subtract the number of places it moves from the power. So let's look at this. Notice this one is not proper scientific notation. The issue is that we have 2 digits up in front, not one. You're only supposed to have 1 digit in front of your decimal point. That's how you get in proper form. So we've got 2 digits there. We need to fix it. It says if you're required to put this into scientific notation, which, like I said, if they say that, it always means proper. You need to put the numeric part and fix that to 4.26. We need to shift that decimal one place to the left. So if the decimal moves one place to the left, remember Lars tells us to add the number of places we moved, which was just 1, to the original exponent, which was 11. So notice I've showed my work down here. 42.6 times 10 to the 11th equals, notice I moved the decimal one place to the left. Now I have a single digit in front of my decimal. But to counter that, because this now changes how many powers of 10 we would be multiplying by, we add 1 to the power. Okay, so that gives us a 12. To verify this, I'm going to take my calculator out and show you that 42.6 times 10 to the 11th is equivalent to 4.26 times 10 to the 12th. This just happens to be the proper notation for scientific notation. So they're both the same number value. It's just one is in correct format. So this is 42.6 times 10, and we're going to do to the 11th. That was the original problem. So if you notice, that is, let's see, that's ones, thousands, millions, billions. It's a trillion. 4,260 billion. Okay, that's the original number. Now, I fixed it to proper scientific notation. Let's see if that's still the 4,260 billion, because it should still be the same exact number. We just fixed the format. So 4.26 times 10 to the 12th is again 4,260 billion. If we had done the wrong rule, if we hadn't added instead of, and we had actually subtracted, which is not what you're supposed to do when you do left, you would notice that our two answers don't match each other. So that's how, if you ever question it, you can look at your original answer and look at this one, type them both into your calculator using your exponent button and see that they actually come out to the same number. That's how you know you did it correct. Okay, so notice here's one where we have a number that's, it's got a digit in front of the decimal, but it's not a 1 to 9. So again, still the problem. To get that to be fixed, we have to move it to the right 2 places so that we'd have a 5 in front of our decimal place, okay? So the numeric part out front needs to be 5.6. This will require moving the decimal 2 places to the right. And remember, right means we then subtract. So we'll subtract 2 because that's the number of places we move to the right from the original exponent of 7. So I showed my work down here. Move your decimal 2 places to the right, subtract that 2 from the power, and then you get 5.6 times 10 to the 5th. Okay. And again, I could verify that these two are the same. This one is just proper scientific notation. Okay, so we're going to fix a couple. So I have 42 times 10 to the 8th. Notice my decimals right here. This is a problem because we have 2 numbers in front of the decimal point. So we're going to move this left 1, which means we're going to add 1 to the power. So this would be 4.2 times 10 to the 9th. That would be the correct form. This next one, notice that I have a not a 1 to 9 in front. I do have a digit in front, but it's not 1 to 9. So I need to move this 2 places to the right until I have a number that's a 1 all the way up to a 9. So any of those integers that is a 1 to 9 in front of my decimal point. So that would be that 7. Now, when you when you move 2 places to the right, we subtract the number of places we moved from our exponent. Sorry, I'm trying to talk too fast. So it's 7.8. And then 6 minus 2 would be 10 to the 4th. Okay, let's look at another one. I'm actually going to write it over here because I'm running out of room and they're getting a little crowded. Okay, so for this one, this is number 7. This needs to move 1 place to the left because I have currently 2 digits in front of my decimal point. To be proper, we're only supposed to have 1. And then this right here would then be 8. And you don't drop off any digits, so it'd be 0.32 times 10. And remember, if you move to the left, we add 1 to our power. So you have to be really careful here. This is a -4 plus a 1. So that ends up, if you type that in your calculator, that's a -3. Okay. And then the last one on this part, 0.07 times 10 to the negative 8. To put it in proper scientific notation, we need that decimal to have a number in front of it that's a 1 to 9. So I'm going to move it 2 places to the right so that 7 is in front of the decimal. When you move to the right, you subtract from the power. So it's the number of places we moved it. And then this would be 7 times 10. And then when you put this in your calculator, negative 8 minus 2 more is negative 10. Okay. Because they're both negative. So it's going to stay negative. Okay. So let's look at how this applies to what we were doing earlier. If we were multiplying our scientific notation numbers together and we get an answer that's not proper, we need to fix it before we circle or type in our final answer. So notice I have one worked out. It's 3.8 times 10 to the 4th times 3.5 times 10 to the 7th. I multiplied the two number parts together. And since we're multiplying all of this, we're going to add those exponents on the base 10. So I end up getting 13.3 times 10 to the 11th. Now the problem with that is there's two digits in front of my decimal. We need 13.3 to be rewritten as the 1.33. So that's moving one decimal place to the left, which means add 1 to the power. Remember, Lars, left add. Okay. So I wrote my work down here. 13.3 times 10 to the 11th would be then equal to 1.33 times 10 to the 11 plus 1, which we would then say is 1.33 times 10 to the 12th. Okay. So that's proper form. Okay. So we're going to try some together. If any of these have a rounding issue, I think I had one that didn't divide evenly, so we might have to do some rounding. So we'll talk about that in a minute. But let's do this one first. This is multiplication. So 7.2 times 8.3. We're going to write our answer out. So that's 59.76. Okay, that's the number part. Then we're doing 10 to the second times 10 to the negative 6. So that'd be 10 to the negative 2, or excuse me, positive 2. The 6 was the negative. Positive 2 plus negative 6. So if you add those together, that's a 10 to a negative 4. Okay, so this is not proper scientific notation. We need that decimal to move one place to the left to fix that, which means we add 1 to our power. So my final answer for this one would be 5.976 times 10 to the negative 3, because negative 4 plus 1 is negative 3. Okay, now we're doing a division one. So remember, with division, you have to remember you're dividing the numbers. We'll have to do that. First one divided by second one. And then when we do our times 10 part, we're actually subtracting the power. So it's 11 minus a negative 3, because top power minus bottom power. That's a minus a negative, so that's going to end up being plus plus there. Okay, so this is just to get our initial answer before we check if it's proper. Okay, so 4.31 divided by 6.21. Now, this is the one I thought. So we're going to round our final answer. Yeah, because this one has a lot of decimals, to 2 decimal places. And this would have been instructions you would have had in Newton. I think I just didn't copy it over when I was looking for examples. So you can't just round this right now. If I round it right now, I'm not technically in proper scientific notation. And we talked about this in class. We said, if we're not in our final format yet, we're not supposed to round yet unless they tell us to round at a specific step. This says round our final answer to 2 decimal places. So we're going to write this out to maybe 6 or 7 decimal places just for right now, so that we don't lose any of those possible rounding numbers. So 0.69. That should be enough for us. 40. And then we have 4. I'll do 4186, and then I'll just put the dot, dot, dot. Because that's more than we need for the rounding rule at the end. So again, we know this keeps going, but right now this will be enough for us to work with. Times 10, and then 11 plus 3 would be 14. Remember, we were doing minus a negative. Okay. Now, want our final answer in scientific notation. So we have to fix this before we can round to 2 decimal places. So this needs to move one place to the right so that we have a number 1 to 9 in front of our decimal point, which means when we move right, we subtract 1 from our power. So now I'm going to have 6 point. Now this is where I round to 2 decimal places. So my 4 is in the second decimal place. So behind it is a 0, so it will not bump up. So this is rounding to 6.94 times 10 to the 13. So that's how you handle one. If it has rounding in it, you have to do everything you can to get it in the final format first, then follow your rounding rules. Okay. All right, let's look at two more division ones. We have 8.9 divided by 2.2. So again, this one's another one that goes on for a long way. So I'm going to write this out to 6 or 7 decimal places. So 4.0, and I think it was just a bunch of 4 5s repeating. Yes, after that. So 4 5, 4 5, 4 5, dot, 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 dot. Our exponents is subtraction because we're dividing here. So it's 7 minus 3. That's a pretty basic one. So that's going to be just 10 to the fourth. And they want us to round it to 2 decimal places or to two places as needed. That's going to be, that doesn't make sense. I think maybe I copied the instructions from the wrong one because this wants our final answer in standard form. So I believe this is supposed to be round to the whole. Okay. The nearest whole. So I think I just miscopied the directions. So we're going to fix that. The reason I say to the nearest whole is because if this is supposed to go in standard form, we're supposed to be getting it out of the times 10 to the fourth. We're supposed to actually turn it into a real number. But before I do that, I'm just checking. This is proper scientific notation, so we're good there. What we learned in class is that if you times by 10 to the fourth, you're really moving your decimal 4 places to the right. Now you could just type this in on a calculator to see this and say, I'm going to times this number by 10 to the fourth, because you're going to put it in a regular number form instead of scientific notation. So notice that's 40,454 and then 0.54 forever. Okay. That's exactly what I'm getting when I move my decimal 4 places to the right, since it was a positive exponent. I'm getting 40 and then 454. They told us, I fixed this. They told us to round to the nearest whole number. So if we do, that would be 40,455 because the ones place would be this 4 and the decimal would be right here once we move it. So the 5 is after that, and that would round that up to a 5. When we're rounding to the whole number, you're rounding to that ones place value. Okay. All right, and then our last one of this type before we have just a couple more, and that'll be the end of 1B1. We have 8.9 divided by 6.2. Again, this one goes on forever, so this one's scientific notation. We're gonna do the final answer to 2 decimal places, just to make sure we match with something you might see in your homework. So 2 decimal places. And that makes sense when we're staying in scientific notation. Okay, so I'm gonna write this out to, like I said, about 6 places or more because I don't want to round until the very, very end. So this is 1.43. 548, and then I think it was a 7, no, a 3, then an 8, 7, but we don't need that much. And then we're going to get our power. So 15 minus 18 would be 10 to the negative 3. Now, I don't need to shift this unless it's not proper scientific notation. So because they're wanting scientific notation, they want a single digit in front, which we do have. That's a 1 to 9, and this needs to be an integer. So we're good there. Now we're just following the rounding rules. So to 2 decimal places, since I don't need to make any adjustments here, this is already proper. We're looking at the 3, and the 5 is going to bump it up. So this is roughly 1.44 times 10 to the negative 3. So that's a rounded, so you don't have to write all of those decimal points out because it went on forever. Okay, so now we've got these last little ones. These are using word form. This will come into play when we get into these application problems later on for our next class session. So you're using the fact that we learned in class that million, billion, and trillion are powers of 10. So I'm going to write this first just by converting these to their power of 10. So we learned that million was 10 to the 6th, billion was 10 to the 9th, and trillion was 10 to the 12th. So I'm going to write them in a form that looks similar to scientific notation, but it may not be proper. Okay, so we got 210 times 10 to the 6th. We got 0.6 times 10 to the 9th. And then we got 32.4 times 10 to the 12th. Now, none of these are in proper scientific notation. So we're going to have to adjust all of them using LARS, an acronym. So notice this one has 3 digits in front of the decimal point. We only are supposed to have a single digit that is a 1 to 9. So I'm going to have to back this up 2 places to the left. When we use left, remember left means add the number of places you moved to your power. So this would just be 2.1. You can write the 0 if you want, but it doesn't change that number. 2.1 times 10 to the 8th. So this is the correct form for that first one. Now this one is a little different. The decimal's in front. So we have a non-1 to 9 up front. We have a 0. So we need to actually bump this to the right one position. So when you go to the right, you subtract the number of moves you made from the power. So this will just become 6 times 10 to the 8th. And for my last one, I need to bump this one place to the left to be proper notation. So 3.24. And then when you move left, you add 1 to the power. So 12 plus 1 is 13. All right. Hopefully that helps you get the 1B1 homework all completed up. We'll be finishing 1B2. That's where we're going to start when we go back to class next week. And you'll notice the adjustments to the homeworks and quizzes if you check our Ivy Learn calendar. Have a wonderful weekend.